Assalamu alaikum wa rahmatullah. Today I will continue explaining Unit 1, Lesson 1, Part 2. In this part, we'll learn how to solve two equations of first degree in two variables x and y algebraically. In the previous session, we studied how to solve two equations graphically by using graph. Today, I will solve the two equations together using algebraically method. Let's start our lesson today. Solving two equations of first degree in two variables x and y in R2 algebraically. Example number 1. Solve the following pairs of equations algebraically, and state the position of two straight lines. This example is the same example which we have studied or which we have solved in previous session by using graphically method. So I will solve by using algebraically, then I will compare between the two answers. Are the two answers the same or not? Now, here I have two equations. This is the first one and this the second. To solve two equations algebraically, firstly, determine the position. This is very, very important point. Why? Because if the two straight lines parallel or coincident, I don't need any other steps. I don't need any other methods. Just determine the position, then I will write the answer directly. But if the two straight lines are intersecting, so I need to continue solving to find the solution set. Let's see. Here I have two equations, 4x plus y equals 3, the other one 4x minus y equals 5. To determine the position by using the two equations algebraically, I will put the two equations under each other. So this is equation number 1 and this equation number 2. So I will write equation number 2 under equation number 1. 4x minus y equals 5. Then I will find the ratio between the coefficient of x in the first over the coefficient of x in the second equation. So I will write 4 over 4. And also the coefficient of y, I will use another color, the coefficient of y over the coefficient of y in the second equation. So I will write 1 over, yes, negative 1 here. Now I will write the ratio between c and c. Where is c? 3 and 5. 3 and 5. 3 over 5. Of course, here the three ratios are different. Why? Because 4 over 4 equals 1. 1 over negative 1 equals negative 1. Here 1. Here negative 1. And here 3 over 5. So, if the three ratios are different, the first ratio not equal to the second, not equals to the third. In this case, since the three ratios are different, therefore L1 intersect L2. Here, the two straight lines are intersecting lines. So I need to continue solving to find the solution set. But if the two straight lines parallel or coincident, I can write the answer directly. So how to continue solving to find the intersection point, the solution set of the two straight lines? I have two methods. You can use any one of them as you like. Substituting method and omitting method. So substituting method. From its name, substituting method. So I will use one equation to substitute in the other. I will use equation 1 to substitute in equation 2, or vice versa. I will use equation 2 to substitute in 1. This is very important. Use one of them to substitute in the other. After putting the equation in form x equals or y equals. Now, here I have equation 1, 4x plus y equals 3. So, I will put this equation 1 in form y equals 3 minus 4x. This is equation number 1. I will use equation number 1 to substitute in equation number 2. Okay? So, by substituting, no, I will write the equation number 2 firstly, then continue solving. Equation 2 for x minus y equals 5. Okay, this is equation number 2. Now, by substituting, using equation 1 to substitute in equation 2. So I will write for x minus y, I will write the value of y instead of y. So open bracket 3 minus 4x, open the bracket, equals 5. Now remove the bracket. For x minus 3 plus 4x equals 5. Now collect the like terms. 4x plus 4x equals 8x. And negative 3, move negative 3 to the other side. Then 5 plus 3 equals 8. Now I have the value of x. X here equals 1. This is the first coordinate, the x coordinate of the intersection point. Now, how to find the value of y? I will use the value of x equals 1, to substitute in equation number 1. By substituting in equation 1, then y equals 3 minus 4 multiplied by 1, the value of x. So the answer here will be y equals negative 1. Now I have the two coordinates of the intersection point, x and y. So the solution set here equals 1 and negative 1. How many solutions? Equals 1 solution. Only one point, intersection point. Now you can use other method. This method is called omitting method. Omitting method. Again, omitting method. What the meaning of omitting method? Let's see. In the omitting method, I will use the form of the equation x. In omitting method, I will use the form ax plus by equals c. Of course, the two equations here in this form. So I will write the two equations under each other. I will write for x plus y equals 3. This is number 1. The second equation for x minus y equals 5. In this method, omitting method means I will put the coefficient of x or y in one equation is additive inverse of the coefficient in the other. Again, I need to put the coefficient of x or the coefficient of y is additive inverse of the coefficient of x and or y in the second. If I look at the equation, the coefficient of y in the first equation and the coefficient of y in the second equation, I can see here the coefficient of y here positive 1 and the coefficient of y in the second equation negative 1. So one of them is additive inverse of the second. By adding the two equations, I will find the value of x. Let's see. By adding the two equations 1 and 2, therefore 4x plus 4x equals 8x. Positive y and negative y cancelled. 3 plus 5 equals 8. Now I have the value of x equals 1. Okay, so this is the coordinate of the intersection point, the x coordinate of the intersection point. To find the y coordinate, by substitute in any equation of them, 1 or 2. By substituting in equation 1. So for 4 multiplied by 1, x equals 1. 4 multiplied by 1 plus y equals 3. So y here equals 4. 3 minus 4 equals negative 1. So the solution set here equals, open braces, order pair 1 and negative 1, and number of solutions equals 1. Now compare between the answers. Here the answer in first method by using substituting method, the answer, the solution set 1 and negative 1, and also by using omitting method 1 and negative 1, and the number of solution here 1 and the number of solution here 1. And also in previous session, in using graphically method, the answer is the same. Okay, so if I solve by using graphically, by using algebraically, substituting method or omitting method, the answer will be the same. Okay, now let's see another example. Here I have two equations and I want to determine the position and find the solution set by using algebraically method. Firstly, determine the position. Determine the position. To determine the position, write the two equations under each other in form, this is condition, in form ax plus by equals c. The two equations here in this form. So I will write 2x minus y equals 3, and the other one 4x minus 2y equals 6. Now find the ratio between coefficient of x in first over coefficient x of second, coefficient of y in first over the coefficient of y in second, c over c. So I will write 2 over 4 and yes, negative 1, not 1, negative 1 over negative 2. The coefficient of y here negative 1 and here negative 2, and 3 over 6. Now find the value, find the ratios in the simplest form. Here half and also here half. and also the third ratio is half. Now, since the three ratios are equals, therefore the two straight lines L1 and L2 are coincident. The two straight lines exactly the same. The two straight line coincident. One of them lies on the other. So I will write the answer directly without using omitting method, without using substituting method. So I will write solution set here equals coincident means any point of the first is the solution set in the other. How to write it? We studied this before. I will write any point mean x and y, where x and y belongs to R2, and I will write any equation of the two given equations. 2x minus y equals 3. It's a very, very, very easy method. So, how many solutions? Number of solution here is infinite number, any point. If I look at the answer by using algebracilly method, I will find the same answer in graphically method. Okay, now third example. Here I have two equations. Determine the position. So I will write x minus y plus 2 equals 0. Sorry, I said before, in form x minus y equals negative 2. Why? Because I want to put the two equation in form. Don't forget this form. Ax plus by equals c in this form. So I will write x minus y equals negative 2, and the other equation x minus y equal 3. The second equation in this form. This is number 1 and this number 2. Then find the three ratios. The coefficient of x over the coefficient of x, 1 over 1, coefficient of y, negative 1 over negative 1, and also the c over c, negative 2 over 3. Now, as we can see here, the first ratio equals 1, the second ratio equals 1, and the third ratio equals negative 2 over 3. Now, I have the first ratio equals the first ratio equals the second ratio. This ratio equals this, but not equal to the third ratio. In this case, when the ratio between the coefficients of x in first and second equals the ratio between the coefficient of y in the first and over the coefficient of y in the second, and not equal to the ratio between C1 and C2, that means the two straight line here, therefore L1 parallel to L2. So I can write the answer directly. When the two straight lines are parallel, therefore L1, therefore the solution set equals phi. Why? Because the two straight lines are parallel. There is no intersection point between them. And number of solutions equals 0. As we can see here, the answer by using algebracilly method equals the answer when we use graphically method. The two answers are the same. Thank you, and see you later in part 3, live applications on solving two equations in first degree in two variables x and y. Thank you and goodbye. See you later.